Hello, welcome to Process Dynamics in Control Group. Now we are going to learn about temperature control of heaters using Arduino Uno R3 and a Matlab software. In the first part of the video, I am going to explain about the components required and will give a brief description about it. And the second part of the video going to demonstrate controlling of heaters using a Matlab software. The components required for this experiment were Arduino Uno R3 and a communication cable between a laptop or a computer to Arduino board and a temperature control shield which is consist of two transistors and two temperature control sensors to sense the real-time temperature of the heaters, and we need a power supply to the temperature control shield of 12 volts and 2 amperes. So in coming videos we are going to explain you how to design this temperature control shield. Now we are going to connect Arduino Uno R3 board with the temperature control shield. After that we are going to supply power to the temperature control shield and connect the communication cable port from Arduino Uno R3 board to a computer. Now we are going to control the temperature of a heater using Matlab software. First, we are going to give a step change in the system and observe and record the data to identify the system. Secondly, we will perform the on-off control on the temperature control shield, and finally we apply the PID controller to the same system and control the temperature of heater at a desired level. So first we are giving a step change to the system 0 to 80 degrees and observe the response. We're gonna run the system for 500 seconds, and whatever the data is recorded will be used for the system identification using system identification toolbox in the Matlab. Here the blue line represents the step change in the system and the yellow line represents the process variable, the temperature of a heater. If the temperature goes beyond 40 degrees Celsius, then we will get a red alert that do not touch the heater. And secondly, we are going to control the temperature of a heater using on-off control method. And we are going to change the initial value to the 35, 37, and the final value to 45, and the sampling time 0.01 seconds, and apply and click OK, and run the system for 500 seconds and observe the system. Here we need to enter the communication port. For the system, it is connected to communication port 5 and hit enter. Here, the red line represents controller output and the blue line represents the temperature of a heater, and the yellow line represents the set point. Finally, we are going to control the temperature of a heater using a PID control technique. In PID control technique, the tuning parameters were calculated using a different tuning methods. For example, Ziegler-Nicholas or Cohen-Kuhn by using the open loop step test data. Now we are going to give a step change of set point of 50 degrees and click OK and run the system for 500 seconds and enter the communication port it is connected to. Here it is connected to COM5. Here, as you see, the blue line represents the controller output and the yellow line represents the set point and the red line represents the process variable, that is temperature of a sensor. I hope you have understood the step test, on-off control, PID control concept using temperature control of a heater. Thank you.